What is an occultation? A lunar occultation of a star or star cluster occurs when the moon passes in front of celestial objects, temporarily obscuring them from our view. The moon, being relatively large in apparent size, frequently covers bright stars, and occasionally, some of the stars in the Pleiades cluster. Because the moon travels near the ecliptic, the apparent path of the sun, and the Pleiades lie close to it, the moon may sometimes cross the cluster and cover some of its stars depending on the inclination of its orbit and the phase it is in. Why are lunar occultations of the Pleiades special? Several factors make these events visually and scientifically interesting. Visual beauty, especially during a crescent phase, when the moon's dark limb, edge, is used, the contrast with the bright stars of the Pleiades creates a striking scene. Rarity. While lunar occultations of stars are common, occultations involving multiple bright Pleiades stars are less frequent and not always visible from all locations on Earth. Scientific value. Amateur and professional astronomers use these events to test equipment, synchronize time, study the lunar limb profile, and refine star position catalogs. When and how to observe. Necessary conditions. To successfully observe a lunar occultation of the Pleiades, several conditions must be met. Lunar phase, a low illumination, such as a thin crescent, is ideal because a full moon's brightness can outshine the stars. For instance, during the event on April 1, 2025, the moon's illumination was only about 16%. Position of the Pleiades in the sky. The moon and the Pleiades need to be above the horizon and unobstructed by trees, buildings, or hills. Clear skies are essential. Exact timing. You need accurate local times of the occultation. The moment a star disappears behind the moon's dark limb, or reappears on the other side, can vary by location. Optical equipment. While some occultations are visible with the naked eye, using binoculars or a telescope greatly enhances the view. A telescope allows better contrast and resolution of fainter stars. For photography, a tripod and a short exposure camera setup are recommended. Example: April 1, 2025 occultation. This event was visible in parts of Europe, including Poland. Some highlights. Moon illumination, about 16%, a favorable thin crescent. Timing, around 10:50 p.m. local time, the dark limb of the moon began covering Electra. 15 minutes later, Merope was occulted. At about 11:50 p.m., the moon reached Alcyone, the brightest star in the cluster. The entire event lasted over 2 hours, with multiple stars covered in sequence. Observation tips. Planning. Use astronomy software, like Stellarium or Sky Safari, or reputable astronomy calendars to find exact local times for your location. Location. Choose an area with a clear view of the western sky, or the relevant horizon, free from light pollution. Optics. A 7x50 binocular or a low magnification telescope is ideal. Wide-field eyepieces help to capture both the moon and the cluster simultaneously. Photography. Use short exposures to avoid motion blur. Set up the camera on a stable tripod. Adjust ISO and exposure to capture both the moon and nearby stars. Documentation. Record the moments of occultation and reappearance of different stars. Take notes or photographs to document the progression. Scientific and technical aspects. Celestial mechanics. The moon's orbit is inclined about 5 degrees to the ecliptic, which means it doesn't always pass directly in front of star clusters near the zodiac. Due to parallax and Earth's curvature, the exact timing and visibility of the occultation can vary based on your location. Star brightness plays a role. Brighter stars are easier to observe during occultation events, while dimmer stars may get lost in the moon's glare. Astrophotography guide. Settings. Use fast shutter speeds and a balanced ISO to avoid overexposing the moon while still capturing stars. Lens/telescope. A wide-angle view helps capture the entire event. For detailed shots of individual stars being occulted, use higher magnification. Timing. Take continuous photos or time-lapse sequences to document the moment stars disappear and reappear. Post-processing. Adjust contrast and brightness in editing software to highlight the stars. Stack multiple images if necessary. Predicting occultations. Astronomers rely on lunar ephemerides, star catalogs, and local coordinates to predict when an occultation will occur. Calculations involve the precise moment when the moon's limb aligns with a star's position, often using advanced software and geolocation data. Historical examples and future events. Notable observations. November 13, 2008. Multiple stars in the Pleiades were occulted. Amateur astronomers in Poland used Dobsonian telescopes and binoculars to record times and take photos. July 18, 1990. Observers in Krosno, Poland documented occultations of several Pleiades stars with precise timing. April 1, 2025. A widely visible event with occultations of Electra, Merope, Alcyone, and more observed across Europe. Cycle and frequency. Occultations of the Pleiades by the Moon occur in roughly 6-year cycles, depending on the relative positions of the Moon's orbit and the Earth. Visibility varies by region and time of year. Some events will be better seen in Europe, others in North America or Asia. After 2029, it is expected that these events will become less favorable for observation in certain parts of the world for a while. Cultural and symbolic significance. The Pleiades have held deep meaning in many cultures, from ancient Greece as the Seven Sisters, to indigenous American traditions, to the Japanese Subaru, which means Pleiades. Celestial events like occultations have often been viewed as omens, markers of time, or even spiritual symbols. For modern astronomers and skywatchers, such events are reminders of the dynamic and ever-changing nature of the night sky. Why you should watch. Spectacular visual effect. The contrast of stars disappearing and reappearing behind the moon is stunning. Educational value. Great for students and astronomy enthusiasts to practice real-time observations and improve skills. Accessible astronomy. You don't need expensive gear. A small telescope or binoculars are enough. Personal experience. It's a chance to feel connected to the cosmos and witness a rare, natural alignment. Challenges and limitations. Weather, clouds, fog, or urban light pollution can obstruct the view. Low elevation. If the moon and Pleiades are close to the horizon, atmospheric distortion can affect visibility. Brightness. Even with a crescent moon, glare can obscure fainter stars. Timing precision. You must be prepared and on time. With accurate data, delays or poor location may result in missing key moments. Conclusion. The occultation of the Pleiades by the moon is a rare and beautiful celestial event that blends aesthetic beauty, stars vanishing behind a glowing crescent moon, scientific precision requiring timing, calculations, and observation, accessibility, available to anyone with interest, patience, and a clear view of the sky. In ancient times, events like this inspired stories and myths. Today, they inspire curiosity, photos, and scientific exploration. And above all, they remind us that the sky above is alive with motion, rhythm, and wonder, and it's always worth looking up.